at Khan Academy for a little bit, and I currently do freelance consulting and research. I'm going to talk about exploring high school math with GeoGebra and Desmos. These are great little tools for people, high school teachers, authors, activities, and for high school students to play around with stuff. I'm going to have some audience participation in a lightning talk that's crazy or just crazy enough to work. But what I need you guys to do is keep with me, no hesitation, okay? We're going to look at diagonals and quadrilateral first. And what I want you to think about is what do you notice and what do you wonder about this image? Who wants to notice something? B, yeah.
E stays on the line between D and D.
E stays on the diagonal between B and D, great. Noticing, anyone else?
And on the diagonal between A and C.
Also on the diagonal between A and C. So E is on both diagonals. The intersection of both diagonals, great.
Are the length of all this line sequence going to become equal when it's a rectangle or if it's an actual?
When are these line segments equal? Well, I think maybe people didn't quite notice yet that EC is purple here, and that's the length of a vertical segment there. Anyone want to wonder something? Actually, that was a great wonder. When they're all equal, what does that mean?
Yeah, just a second.
What happens if I move C inward of E and make this thing?
What happens if you kill my quadrilateral? That's a great question. All of these are going to be interactive. There are links at the end. Okay, moving on. Factoring. Who wants to factor that for me?
Not me.
Yes.
X plus 3, X plus 5.
How do you know?
Because 3 plus 5 equals A and 3 plus 5 equals C.
Okay, I remember that. Doesn't matter. Go. Great. So we're going to do it with integers. Integers are the most desirable way to do this. You can factor it without integers. That's easy. But if you get integers, then it tells you something nice about the parabola. You can find the x-intercept there, -3, -5, because that's what makes that 0. -5 would make that 0. -3 would make that 0. I'm just going to remember that this one worked with integers. This actually worked with integers. If B is 8 and C is 15, I'm just going to put a little checkbox at 8, 15. That means that there's lots of checkboxes to check then. Which ones work and which ones don't? We can go up the ladder out of abstraction and factor every polynomial that you want. The blue ones factor with the integers. Who wants to notice or wonder something?
Wow.
Diagonal.
It looks like little lines.
What do you notice?
It actually looks like it's starting to be multiple lines at different slopes.
You're noticing maybe some patterns in the blue about straight lines in the blue. B, what do you notice?
Does it have to do with prime numbers?
Maybe there's a connection with prime numbers. Tell me more about that.
I don't know.
Okay, that's great. Paul?
The pink numbers are complex numbers.
The pink numbers are when the B and C pair does not factor over the real numbers. It requires a complex.
What's going on with this parabola?
What is going on with that parabola? Well, remember when it was at 815, and you'll see it at the very start, we had integer numbers here. What happens if the parabola what happens when we're in the pink section? What do you see in the parabola? No x-intercepts, no reals. What if it's in the gray section?
Non-integer.
In our more mappy terms, I guess B squared minus 4AC is not a perfect square.
B squared minus 4c, she's getting into a little bit of algebra of you can verify which things are there. Great. One last noticing or wondering.
When C equals B, it always factors.
When C equals B, it always factors. Is that true? I don't know. Moving on. If it doesn't factor, there's another trick you can do. You just take that parabola and just push it down, and then see how far you need to go back up. That's a nice trick. You can just complete the square. It's a nice thing to pair with completing the square on algebra tiles. Okay, moving on. So let's think about triangles now. So let's do some more noticings and wonderings. What do you notice about this? I want to see different people raising their hands. Thank you. I teach high school. Yes. What's your name? Surya? Surya is noticing sometimes there's a triangle, sometimes there's not. And he's created some labels A and B for some of the sides he's talking about. What else does someone notice?
It's like the
Sorry, yes.
that you can make.
Ben,
Is that maybe making a circle or something?
you're noticing something about the recorded points here. What do you see about the recorded points?
I mean, there's space, but I would still expect that to work with integers.
Why is there a point recorded there? Maybe is.
Yeah.
Because it's when the sides add up to the same thing.
Well, actually, they always add up to 30. It's always 30.
They're only sometimes triangles.
They're only sometimes triangles, and these are where they are. Yes. I don't know. So, when you're in a classroom, it's a very different environment audience for an explorable explanation because you have a very captive audience. They're required by law to be there. But if you want to make it, can't actually. That doesn't matter. Kids will be tardy and absent if they are not interested. So you need to invite them in and show them something interesting, but you can't tell them the thing in the way that you have to tell people on the internet. Like on the internet, they're going to click away unless you give them what they want a little bit. In the classroom, you can kind of be a little more patient. So with this activity, it's kind of similar to the last one, the triangles. Except students are tasked to see if they can rescue Grumpy Cat with the crane that I've given them. Actually, there's 3 Grumpy Cats in the tree. And you just can't quite rescue all the Grumpy Cats because of some reasons that people have been thinking about earlier. What's great in the classroom, this is a tool called Desmos. The other ones you saw were GeoGebra. With Desmos, you can aggregate what students have done. So if you have a classroom full of students and they all rescue this Grumpy Cat here, maybe you give them different crane hinges. Maybe one crane has a short arm and then a long arm. Maybe the other crane has equal arms. Maybe you give them all kinds of lengths. You can aggregate and show them the aggregate graph, and then maybe see another pattern of how the working rescues work. A big philosophy in Desmos' activity builder guide is that you want to let students be right and wrong in different and interesting ways. So it's that when you see the aggregate, you can group together what they're thinking and create a discussion within that class around it. So when you're in a classroom, you want to support the exploring and withhold your explaining so that the students can contribute, because the learner has a lot of knowledge to share. If you'd like to try that particular Grumpy Cat one, there's a Desmos activity here. I'll post that around if you want. There's another Desmos activity for if you need another break. And here are all the links to things. I'll put this also somewhere. Thank you.